Hello, everyone. This is Mrs. Okoro, and today we're going to talk about exponential translations using Desmos. All right, so first let's begin. What is a translation? We've talked about this before. A translation is just a shift or change in a function. All right, the shape is still going to be the same. It's still going to be the same type of function. We're still going to talk about exponential functions, but now they're just moving. They're shifting either left, right, up, or down. This example shows the general shape of an exponential function. There will always be a y-intercept, and there may be an x-intercept. There will always be a horizontal asymptote, a line that is not part of the graph, but which the graph approaches more and more closely without ever crossing. So let's take a look at this graph that I have here. Notice going from left to right, our graph is increasing. So this would be an example of exponential growth. And like I said before, there will always be a y-intercept, and the y-intercept here is 1. And just in case you forgot what the definition of y-intercept is just a point where the graph crosses the y-axis, and it crosses our y-axis here at 1. This graph does not have an x-intercept, but like I stated before, there will always be a horizontal asymptote. An asymptote is just a line that is not part of the graph, but your graph will get close but not touch or cross. A horizontal asymptote for this function, or for this graph, is y is equal to 0. It is this x-axis. Notice it gets very close to this line here, the x-axis, but it's not going to touch. All right, so let's take a look at some more translation examples. Rules. So we have horizontal shift, meaning our graph can go left or right. Vertical shift, our graph can move up or down. Or we could have a reflection across the x-axis, or it could reflect across the y-axis. Once again, these are not all of the transformations that can happen. Today, we're just going to focus on the vertical and horizontal shift. So let's start with this first example. This says, let f of x equal to raised to the x power. This is going to be the parent function that we're going to work with today. And the question says, what happens when f of x is replaced with f of x plus 5? And notice the 5 is inside the parentheses. Is there a new y-intercept? Is there a new asymptote? So first, let's determine what the y-intercept and the asymptote is for this parent function 2 raised to the x power. So I'm going to go to Desmos, which is an online graphing calculator, and graph. And here's my keyboard. I'm going to type in f of x, and that is equal to 2, and then raised to the x power. So I'm going to use this button, A to B, and then put x in the exponent. So here is my parent function 2 raised to the x power. And notice my y-intercept for this one is 1. And my asymptote is the x-axis. It's this horizontal line here. Like I said, an asymptote is just a line. It's not part of your graph, but your graph is going to get close to it, but it's not going to touch or cross. So for this one, my asymptote is y is equal to 0, and I can just graph that. Let's see it. There it is. Line here. All right, and now the next example where they ask us what will happen when we change f of x to f of x plus 5. Put that in. All right, so this is my graph in green, right? F of x plus 5 is in green. So I'm going to zoom out so I can see all of it. And the question was there a new y-intercept? Yes, there was, or there is a new y-intercept. So let me zoom out so I can see the y-intercept. And the y-intercept for this one is 32. Is there a new asymptote? Since our graph didn't shift up or down, it just moved to the left 5 units. Our graph has the same asymptote as the parent function, which is y is equal to 0. Okay? It says, what happens when f of x is replaced with f of x plus 5? All right, our graph shifts 5 units left. Is there a new y-intercept? Yes, there is a new y-intercept. Our y-intercept is 0, 32. Right? Is there a new asymptote? Nope. It's the same, which is y is equal to 0. It's the same. Make sure I put that. It doesn't change. All right, we got all this information from Desmos. All right, let's look at another example. We're using the same parent function, f of x is equal to 2 raised to the x power. This time, they ask us, what happens when f of x is replaced with f of x minus 2? With a minus 2 inside our parentheses. All right, so once again, we're going to go to Desmos. And I'm going to delete this one out. I'm going to adjust this. And now this time, I'm going to say f(x) minus 2 inside the parentheses. And now my graph, the new graph is in purple. So I started off with this red one. This is the parent function. And now it has moved to this purple one. Notice my graph moved 2 units this time, 2 units to the right. So since it moved 2 units to the right, I do have a different y-intercept. My y-intercept is 0.25, or the same thing as 1/4. And since my graph did not shift up or down, my asymptote is still y is equal to 0. So let's answer the question, what happens when f of x is replaced with f of x minus 2 with the 2 inside the parentheses? We have a shift of 2 units right. Is there a new y-intercept? Yes. The y-intercept was 0, 0.25, or we can give the fraction, which is 1/4. Is there a new y-intercept? No, it's the same, which is y is equal to 0. All right, so the numbers inside the parentheses determine whether we move left or right. Okay, let's take a look at this next one. What happens when f of x is replaced with f of x plus 2, and the 2 being outside the parentheses? We'll have a different kind of shift here. So let's go to Desmos and see what happens. Okay, so I'm going to type f x, like I said, plus 2. It's on the outside. All right, so the parent function is in red. And when I added 2 to the graph, my graph shifted up 2 units. So the number outside the parentheses determines if my graph moves up or down, shifts up 2 units. Notice my y-intercept has changed. Not only that, the entire graph shifted up. So now we have a new horizontal asymptote, right? When our graph shifts up or down from the parent function, the asymptote changes. This one is now y is equal to 2. It coincides with the number that we're adding or subtracting. So our asymptote is y is equal to 2. Let's go ahead and check and see so you can see what I'm talking about. Y is equal to 2 is this line right here. It gets close to it, but it's not going to touch. It's very close to it, but it's not going to touch. So my asymptote is y is equal to 2, and my new y-intercept is 3. All right, so let's answer the questions. What happens when f of x is replaced with f of x plus 2? Our graph shifts 2 units up. So we have a vertical shift, moving up 2 units. Is there a new y-intercept? Of course. It is 0, 3. Is there a new asymptote? Yes. It is y is equal to 2. Okay, this next one says what happens when f of x is replaced with f of x minus 5. Okay, let's take a guess. What do you think is going to happen? Our graph should be moving down 5 units, but let's verify using Desmos. All right, notice my parent function is still in 2 raised to the x, and now I'm just going to type in f of x minus, and the new function is this one down here. So our y-intercept is at -4, and our asymptote, like I said, it correlates with this -5, and so if we have -5 here, our horizontal asymptote is going to be y is equal to -5. So let's answer the questions. All right, what happens when f of x is replaced with f of x minus 5? Our graph shifts down 5 units. Is there a new y-intercept? Yes. It is 0, -4. Is there a new asymptote? Yes. Y is equal to -5. Get that from here as well. All right, so I'm going to stop here. I should be able to answer the questions on your assignment for today. Have a good one. Bye.